Now that we've reviewed interval notation, now we can talk more about domain and range, especially given graphs. So let's look at example 1. The function is these 4 points, right? That these 4 points are representing the function. The domain is the x values. Now in this case, there's no decimals. I'm not shading between any of these points. I'm not connecting them with some kind of curve. So if it's just a list, we're going to use curly brackets. So the x values are -3, -1, 2, and 5. That's the domain because those are the x values that we hit on those 4 points. Range means y values. So we go through the same 4 points, finding y values. Now these first 2 hit the same y value, so I don't need to put it in twice, just once is fine. And then 4 and -3. Now, if it bothers you that that's not in order, you can certainly put in order. I still was going left to right. I was putting in order of the x values, but you could go from like lowest y to highest y, but you don't have to. Sets don't have to be in order. Intervals, on the other hand, have to be in order. So intervals always go from low to high. So if it says interval notation like this next one, it has to be something like low to high. And maybe there's parentheses, maybe there's square brackets, but intervals have to be in order. Curly brackets don't, they're just a list of numbers. So let's do one where we need an interval. So in this case, domain is still x values. I need the lowest x value and the highest x value. So it's like we're going left to right. The leftmost x value is -3. This has a filled in point, so we're going to use a square bracket on that. So the lowest x value is -3, and we can touch that lowest x value. If we go all the way to the right, the highest x value this graph touches is 4, but it actually doesn't touch 4. It gets infinitely close without touching it. So 3.99999, but we don't include 4, and that's what those parentheses for. So it has to go low to high in an interval, and we use the parentheses and square brackets to indicate whether we're touching or not. Set builder notation would be the set of all x such that, and I'm just going to say that x is between 3 and 4. I can touch 3, but not 4. If we put our set builder notation in order from low to high, we should always be using less than symbols because it's lowest to highest. So -3 is less than x and x is less than 4. It goes in order that way. All right, let's do the same for range. Range is up to, down to up. We don't want to start with the high values. We want to start with the lowest y values to the highest. So the lowest y value is -4, and I'm touching it. So that's a square bracket, -4. The highest y value this graph touches is 2. It's not, don't look at the x's. If we're doing range, we have to look at just y's. So the highest y value we touch is 2, but we're not touching it, so we use a parenthesis. The set builder notation of this is the set of all x such that, and then we put it in lowest to highest, just like before. I'm going to switch it to y though. Instead of the set of all x, range is the set of all y. As long as these two variables match, it doesn't really make a difference, but this way it's really emphasizing that the range are the y values here. All right, so hopefully we see the difference between if there's just a list of separate points versus infinitely many points with decimal values all the way through. It's a very different way of stating domain and range in those two cases. Now, when we're really going to be using this is to look for the domain of a function based on its formula. So there are two domain rules. And they're printed here, but I like to put them in my own words. Domain rule number 1 is don't divide by 0. Hopefully you remember that rule, but if not, let's try it on a calculator. If you tried anything divided by 0, let's just do 8 divided by 0. Nope, it's a big old error message. You can do 0 divided by 8, but you can't have 0 in the second position. So don't divide by 0 is the first rule if we're looking for domains. Rule 2 is no negatives under a square root. Because if you have negatives under a square root, that makes imaginary numbers, and we don't want to mess with imaginary numbers. It's certainly not something we can graph. So those are the 2 rules we need to look out for in formulas when asked about the domain. All right, first example, it says find the domain of this function, x plus 2 over x minus 3. There's no square roots, so I don't have to worry about that. What I have to worry about is don't divide by 0. So the bad value of x would be when x minus 3 equals 0. All right, we can't have the bottom of the fraction equaling 0. Well, that would mean that x cannot equal 3. That's the domain. We have 2 different ways to write that domain. Set builder notation that we've been practicing with is the set of all x such that, and then you just put x cannot be 3. Which isn't too bad, right? It just puts this formal curly bracket thing around what we already found. If we were doing interval notation, it'd be negative infinity to 3, union 3 to infinity. And the way I usually visualize that with like a number line. Basically what we're doing is we're going over to 3 and plucking out that point, keeping an open circle there. So I'm going from negative infinity to that point, skipping over 3, and then going from 3 to infinity. So that's the domain based on just looking at the formula, because I can't divide by 0. Let's do another one. So this one has a square root. So the rule that we're using is no negatives under the square root. So what we're going to do is look for when x minus 9 is greater than or equal to 0. So this would mean 0 or positive, because we cannot be negative under a square root. The piece under the square root is called the radicand. Fancy word. So all I'm doing is focusing on the x minus 9. The plus 4 is outside the square root. I don't care about it, right? I can add 4 to whatever, but I can't take the square root of a negative. So if x were 0 here, 0 minus 9, negative 9, the square root of negative 9 is imaginary. It's 3i. Doesn't work. So we need to find x values that would make this positive, or 0 would work too. So then I just add 9 to both sides. Plus 9 plus 9. That makes x is greater than or equal to 9 is the domain. So, they have found a mistake in this handout. They don't have an x in their set builder notation. So it should be the set of all x such that x is greater than or equal to 9 is the set builder notation, or like they put here, 9 to infinity, but with a square bracket on 9 because we can equal 9. Let's, just to make sure we see that, let's find g of 9. So that'd be the square root of 9 minus 9 plus 4. So that's the square root of 0 plus 4. 0 has a square root. Negatives don't, but the square root of 0 is just 0. So we get a number. That's all it means to be in the domain, is that when we plug in the x value, we can get a number. If we plug in an x value and get a negative, that's not going to be in the domain. So we have to only plug in values that are 9 or greater.